Well, it's 7 p.m.
Yeah,
Welcome to
hi.
Cornerstone Home Inspection Education Center. Tonight we have Bradley Korth from Korth Engineering, and he's going to be talking about septic system design and site features. And I will, if you have any questions, just break in, and we'll hand it over to Bradley. And then Bradley, when you need me to change a page, you just let me know. Just say, Jim, change a page.
Okay, sounds good there.
Okay.
Okay, I'll just kind of briefly go through there what planning on doing there since with an hour presentation. Yep, and go to the second page is fine. And I'm going to go through rather quickly. You can make this presentation available to people that want to look at it afterwards. But for about the first half hour, go through kind of some basic general stuff there regarding septic systems. And then for about 15 minutes, do a case study there on an inspection and a project that I'd worked on several years ago to being that'd be relevant. And then the last 15 minutes, another project there where did some more theoretical calculations to try to determine what if a septic system was operating properly. So we'll start, but feel free to, like I said, I'm not going to go through all the detail by point in this part of the presentation for time purposes, but feel free to anybody to ask any questions and stop me along the way if I'm, like I say, missing a part there that I'm going through too quickly or not. So the first part there, this just shows a basic septic system, a septic tank, a D box. There's all kinds of different types of systems out there. There's what they call conventional systems that people are probably familiar with, the typical pipe and stone or the concrete galleries. And then nowadays there's quite a significant number of what they call proprietary systems, and that which are really to make better use of the space that you have. I mean, conventional systems, in my opinion, they work good, but they take up a lot of space. And with a lot of lots these days in Connecticut, there just isn't the space for conventional systems. So we can go to the next page. Yeah. Okay. Yeah, maybe just up just a little bit there. Jim, just up, put the page up a little bit. Yeah, that's good. Yeah. No, back down a little bit.
There we go.
Yeah, just back. Yeah, that's good right there. And that. And like I said, really the main parts of a disposal system: a septic tank, the lines, the distribution boxes, the leaching fields. You may add in there a pumping chamber if you can't do stuff by gravity. And that. And the way that stuff's done in Connecticut is according to the DPH regulations that are typically revised every 3 years. You usually don't see a lot of changes, but there's some changes, and that they apply to what they call the main area. They don't apply to a reserve area. If you're doing new construction, you have to have a reserve area, which is 100% area for the leaching fields and that. And you have to have what they call suitable soil conditions, which, as it says, you have to have a perk rate of less than 60 minutes per inch. So that's essentially just a hole that's dug into the ground with a post hole digger, and you measure how fast the water goes down. Typically, you do what they call a pre-soak for any type of clays and soils that can swell up, and then you actually do the perk test. The second one there, for a new system, you have to have at least 2 feet of naturally occurring soil, or it's not a code compliant system and you can't develop a lot. That doesn't apply for if you're trying to replace a system or trying to fix a system that's already on site. And then 2 of the basic items that you have to meet, you have to have at least 18 inches to the high groundwater mark from the bottom of your trench and at least 48 inches to ledge. So you can go to the next page. Okay. And everything's based on design flow. For residential, which is, I know what most people are interested, everything's done on a per bedroom basis. And what they figure is that there's 2 people per bedroom for anything 3 bedrooms or less. And each person uses 50 gallons a day, plus they add a 25% safety factor in. So it makes it 75 gallons a day per person or per bedroom, since they figure 2 people. It's all theoretical, and that you're doing 300 gallons a day for, or 150 gallons a day, I should say, per bedroom. So if you had a 2-bedroom house, it'd be 300 gallons per day. If non-residential, they have different types of way you calculate it. And one of the main things that they're looking for, they have what they call MLSS, or minimum leaching system spread, which is just how long a trench has to be from point A to point B. And the reason that that's done is because if you're putting groundwater down a system, that it's going to mound up some. And the idea to not have it mound up and go into your leaching trenches to spread it out. Obviously, if you had a trench that was, just for discussion purposes, 10 feet long, and you put X amount of water down, it's going to mound up higher than if you make that trench 20 feet long. And then if you're doing any type of a building conversion or increasing the flow, a change in use, you have to be 100% compliant. If you're just trying to fix an existing system, you can get a lot of exemptions from the regulations, as long as they make sense. And then they have what they call the long-term acceptance rate, which is, if you look, a lot of it's done on a square foot basis and that, but that's essentially, if you build a new system, it's going to accept a lot of water very well for a period of time, but over a period of time, it's going to go down more and kind of more level off at a point. Now, you may get to a point where it goes down so much that you start seeing problems with the field, where it either backs up into the house or some combination, or sometimes you see on top of the ground, you see the effluent coming out and it smells, and that's typically due to a lack of oxygen in the system. So we can go down to the next one. Yeah, for this is just out of the regulations, that the way that they're done is, how big does your system have to be? That for different leaching products, they sign what they call an ELA, or effective leaching. It's a leaching factor of how much water. Refers to, essentially, when you do the formula, of how much water that it can accept per foot. And like I say, here they show you in square footage is the way they do it there. But if you did the calculation of how do they come up with a particular product, the square footage, it relates to how much flow and that. So what they try to do is make the regulations really easy for people. So instead of having to do all these calculations where you do based on gallons and stuff, that they make it a simple process. Let me go to
Bradley, do you have any comment on condensating heating systems emptying into the septic system?
Yeah, I do actually. The last part of the presentation, I
Okay.
showed there, as far as if you have any type of water treatment equipment there, you have to have a separate system.
Okay.
And that's, so yeah, that's about the last 3 or 4 pages of the presentation. So we'll be going through that.
Perfect.
And yeah, this is just part of the table for commercial building and stuff, that to get how much flow that you need, and that they do it based on different ways. Like for restaurants, and that they do it based on how many seats you have. For industrial building, based on square footage, and they have the design flow in gallons per day. So for like an industrial building, if you look about halfway down, it says 0.1 gallons per day for each square foot. So if you were to try to do an industrial building, you would just multiply. If you had 1,000 square feet times the 0.1, that's how many gallons a day you would have to design it for. And so that, like I said, that's how commercial is done. One big difference in between commercial and residential is commercial alternate. Instead of using this table, what you can do is you can, if you have similar meter readings or you have different meter readings from a year, you can do it based on the meter readings. And really, for both residential and commercial, if you use the tables factors, from a practicality, that you end up using typically a lot less water than what doing just the default calculations. But again, with residential, you're stuck with the default calculations, as opposed to the commercial, where you can do that, a meter reading plus the residential. And
may I ask a question or bring up a point?
Yeah.
My name is Marlo, and I've noticed over the years when we're doing residential inspections, especially, and it's just an observation of mine, if we're on a development where, or in a development where you're bringing in city water, but you're dumping it into septics. Quite often, I'll see a lot more failures in those areas because we're bringing water into the site, but we're not piping it out. And the converse holds true when you're using well water, but putting it into city sewer. I see a lot more wells fail because we're taking water out of the site, but we're not putting it back. We're piping it down the street. In your experience over the years as an engineer, have you seen any such correlation with developments?
Yeah, that is can be one of the problems when you have sites there where you have city water, but you don't have sewer, and that because you are draining the area, and and over time that can make a significant difference. It's one of the things. I've been on the sewer commission when we developed in town, and it's one of the real concerns with bringing sewers in. There's unfortunately no panacea, but yes, I would agree with you that that can be a problem.
I just want to make sure I wasn't alone on that.
No,
Okay,
no. Like I said, no. In our time, I live in a small town, and that was one of the considerations. There, do we want to bring the sewers in? But it's one of the things that there's pluses and minuses. Okay, this next one.
Do you want me to skip?
Go ahead.
Do you want me to skip ahead on a page here, or?
Yeah, well, this one is just a couple of things. That this is just if you have a commercial building and stuff, depending on what they call problematic or non-problematic flue, and it defines that in the regulations. You essentially decrease the credit that you get when you're designing a septic system, or the amount that you need. So essentially, you have to have more septic system based on your flow, and a lot of stuff in the regulations is done on perk rate. And if you notice the perk rate, everything's done in ranges. Like you have a less than 10.1, for instance, and that or 10.1 to 20. So if you do a perk test, you pour the water in the hole that you've dug, and that it doesn't matter whether you get 10.1 or 20, that use the same range. Okay, we can go on to the next page. Yeah, this is just the typical septic tank. And the reason I have this one in here really, and you see the next page too. I mean, a septic tank, essentially it comes in from the house or wherever the generation source is. You have a scum layer, the fluent liquid, and the sludge. And the question a lot of times comes about, how often should I pump out my septic tank? And essentially what happens is all the stuff that's lighter than water, oils and greases and stuff like that, they float to the top, and the stuff that's heavier than water goes to the bottom, and you draw off in between. And how often should you pump your septic tank depends on what type of sludge that you're putting down and how much, and the scum layer, because you don't want that scum layer or the sludge to go out to your leaching fields. Because again, in leaching fields, it really comes down to having oxygen to have the microbes work effectively. It's kind of similar in some ways to a compost pile. What do you do with the compost pile every so often? You go and turn it to give it oxygen. If the oxygen gets deficient, the compost pile doesn't work very well. Well, the same thing with the leaching fields is that if you put stuff down there, a lot of oils and greases or sludge that takes a lot of oxygen, that's when your fields start to fail typically.
What do you recommend for residential, a colonial, family of 4?
Well, let's go to the next page. I think I'll answer your question on the next page.
Sure.
And that. Now, this is one that's just available on the internet. This is a table that essentially looks at the size of your tank and how many people in the household, and tells you how often you should pump your tank. And that this is, like I say, a conservative estimate in that. Because essentially you'll think of, if you have a bigger tank that has more square footage on the top and the bottom, that's going to be able to hold a lot more liquid. So if you compare a 500-gallon tank compared to a 750, you can put, because of the size of the tank, a lot more sludge in the bottom or oils and greases. So does this answer that question for you?
Most residential tanks are 1250 on average, the newer tanks.
No, what it is if you have a 3-bedroom or less, it's 1,000-gallon tank, and then typically for every bedroom above that, you add 250 gallons in that. So if you had a 3-bedroom or a 1, 2, or 3-bedroom house, you'd use 1,000 gallon. If you have a 4-bedroom, you'd use 1,250, a 5-bedroom, 1,500, and so on.
Brad, real quick, a lot of times these houses will start off with 1 or 2 bedrooms and they'll add on and the septic's undersized. Do they force them? Most communities force these guys to increase the tank size?
No, typically you can't force them. And there is one thing in the regulations that you also see happening, that for residential, they have an exemption that if you that allows you to increase your bedroom size by 50% if you've already have an approved system and you're looking to expand the house. So let's say you have a 2-bedroom house without increasing the size of your leaching system, the septic tank or the leaching fields or anything, that you can increase that to a 3-bedroom house. If you had a 3-bedroom house, you could obviously 50%. You can't go to 4.5, but you can increase to 4. But if you had a 4-bedroom, you can increase it to 6. So one thing to look for is, has the house been expanded on, and
Right.
has the septic system not been increased in size because of that exemption? And that's like an automatic exemption as long as you have a code, what they call a code compliant system, which is 100% of the regulations. So essentially, if you have you may see a 4-bedroom house that expanded to a 6-bedroom house and they didn't change the size of the septic system.
And that could be a problem.
It could be, depending on the conditions you have. Now, probably the saving factor is that, again, I talked about how you use that 150 gallons a day, which has a 50% safety factor. And that 50% safety factor is really for 2 reasons. And actually, the primary reason isn't if people use more water, or that's the secondary reason. But the main one is let's say you have a lot of people over at one time. You have a big party or something like that, or a big family event that you may, for a day or a few days, you may generate a lot more wastewater than you normally. Maybe you typically generate 100 gallons a day, and all of a sudden you may go up to 300 gallons a day because you have a bunch of people there. But like I said, the thing to look for is, has the house been increased in the size, but not the septic? And the way to find that out really is, it would be at the health department records. That you go to town hall or wherever the health department is, and look at whatever historical records they have. And if there was they would have to get a permit to increase it. Like I say, it's an automatic thing as long as it's a code compliant system, but it still requires a permit for them to do it. They can't just go ahead and hire somebody to do it, at least not legally.
So basically, you're saying that if it's code compliant or a newer, strong system, they give you a little more flexibility with it, where if you have an older antique house with an older system that might be marginal to start with, they're not going to give you that same leeway.
Yeah, it has to be code compliant to begin with. And that, so now let's say you had a system that wasn't code compliant because you didn't have a big enough septic tank, or you didn't have enough leaching fields to meet. That's just for discussion. Have it say it's a 3-bedroom house and you don't have enough leaching fields to fully meet a 3-bedroom house. You can't use that 50% increase rule.
Well, one other question I had when you showed the diagram of the tank with the scum layer and the sludge. Yeah. There were some concrete tanks we were seeing recently on inspections there were being eaten up, and it wasn't because of the bad concrete, which could have gotten into some of the U.S. tanks that were made back in the day, but it was more discussed about the off-gassing from the septic fields and so forth, making its way back into the uphill tank and the gravity system. And so there was discussion about venting the tank, the lids having a vent on it, and then to prevent odors, putting some kind of charcoal filter or gooseneck on that vent. And that somehow is supposed to save the upper top side of that tank and or the concrete risers, which tend to be the areas of the tank that were deteriorated from the methane and other gases that are produced. Any opinion on that?
Yeah, I mean, you get that. And the other common way of degradation that you would ask about the backflow systems there for water softening, that a lot of times those use salt. And of course, what does salt do to concrete? Is, I'm sure that people already know what it does over time. And that's why they don't allow the backwash, but that regulation hasn't been in effect for too many years. So if you have an older tank they may have been putting backwash in there for quite a number of years. Something to look for.
Well, yeah, salt and concrete don't mix. It's a disinfectant, so it retards the bacterial action. And because it's soluble, it leaves the tank with the water and crystallizes out in the fields. And those are all good reasons not to do it, but we see it anyway.
Yeah, you see it, but it's not legal these days to do that. You have to have a separate system. Like I said, I'll be talking about those separate systems here. This one just talks about this page about who has jurisdiction. Typically, for residential, it's the local health district that has it. Some towns have their own health department, but a lot of towns, particularly smaller ones in Connecticut, that they have health districts where to share the resources and stuff, several towns have banded together. Because the health departments do a lot of other stuff, and it helps them too with having better expertise. The local health that they do restaurant inspections, for instance. So by banding together, you may get for smaller ones a lot better expertise. There's somebody who does septic systems, and then another person who's expert in the restaurants or something like that. And yeah, the other ones, like I said, you can think. Yeah, if you're doing a new system in that, now there's a new system means a house or a building that's never been there, and it's a distinction there between repair. A repair means that there's a previous building there. A repair may mean that you're taking out the whole existing septic system and replacing it, but it's considered a repair versus a new system. And the difference is a new system, you have to meet 100% of the code. A repair, that you can get exemptions. And exemptions can be for a lot of things. It could be something as simple as that you're, for a system, a residential system, you have to be 10 feet from the property line. If you're not 10 feet from the property line for your system, it's considered a repair and they can give you an exemption. Now, obviously, the leaching trenches, they don't know where the property line is, so it doesn't necessarily make a difference in how the system functions. But the code really incorporates really some zoning characteristics is what it amounts to. And that they don't want people just building houses on top of each other. So that's why for a repair, they don't want to say you can't use your dwelling anymore, so they'll make exemptions. Yeah, and this just go back there. I'm not going to go through the whole back page, but that just talks about the process that you have to go through to get a system permitted with the health department. So people can look at that on their own. We can go to the next page. And that. Okay, a lot of people, they hear the term engineered system. And what does an engineered system mean? It means that they have the same technical requirements, but it means that it's designed by a professional engineer. Is that better or worse than one that's not an engineered system? Well, obviously, it depends on who's designing the system. There's good engineers and bad engineers. There's good installers, bad installers, and they all use the same regulations. So there's certain cases where you have to have an engineered system that I have outlined there. And I talked about the system, the new system versus repair, the following thing, where if you're doing new construction or change in use, you have to meet the 100% of the requirements. The repair, you can get various exemptions on a case-by-case basis. Okay, we can go to the next page. And that. Okay, how do you site a septic system? And that you do what they call soil morphology. You look at the types of colors, where the water levels are. Like I say, the two big things are groundwater levels that you have to keep at 18, depending on your perk rate and use, of either 18 or 20 inches above the high water marks, so that the effluent has time to seep into the ground and be treated, and you have to have at least 48 inches for ledge. Then you look at some of the other site characteristics. What other obstructions are there? Sheds, wells, houses, things like that. You have to take that into account, separation distances, and that. And go to the next page. And that. Now, these are things that may help you. Just some practical things of when you go out to a site. I mean, to do investigation that is really a full investigation, you need to bring backhoes out there and different types of, maybe if you're doing existing system, cameras and stuff, and that, which gets expensive. But there's things that you can do to try to at least get a good idea of, that's right, that's good right there, of does it look like there may be problems or not. Again, these are kind of like rules of thumb type stuff. Now, what can you do for groundwater? You can look around. You can look and say, is there streams? Is there ponds? You can kind of look at the vegetation, even if you're not an expert, which I'm certainly not on vegetation. A lot of times people can look and see that, just the type of plants are there, and wet area, slopes, stuff like that. Look around. If you have that type of stuff, you may be concerned about having high groundwater and that. And then if we go down just a little bit there to the ledge, have a picture of me with a hammer there, is how can you, sometimes you can obviously tell because you see rock croppings that are out of the ground, but maybe like in this case, you just see a big piece of, you don't know if it's rock or if it's ledge, and that by just looking at it, and that because it's not like significantly out of the ground. And if you, it's kind of hard to see, but if you look at the picture, I have a hammer in my hand, and yep, you see the hammer right there. And what I'm doing is I'm hitting on the rock, and if the rock sounds like it's really solid, it's probably ledge. If it sounds like a kind of a hollow sound, it is maybe just be a big rock that you can remove. Obviously, ledge you a lot harder to remove than just digging up, even if it's a big rock. So it's kind of, again, it's not overly scientific, but without spending lots of money and time, it gives you an idea of, yeah, this is what I talked about. The next one, I'm not going to go in detail. You can look at it, but I talked about the MLSS being what you're trying to do is just spread out, have a longer thing, depending on a longer trench, depending on how much groundwater that you're putting out, and that so it doesn't mound up and go into your leaching trench. Like I say, people can look at it. We can, unless you have some questions and really want to go into it there, we'll move on, but something to be aware of, the meat. And then I talked about there's different types of systems. There's gravity flow and low pressure. Low pressure is using pumps and that. And it's really, if you look at the state of Connecticut, that they like to do gravity for residential. And why is gravity preferred? Actually, low pressure works better, but you have to maintain pumps and the systems on a regular basis, perform preventative maintenance. And as you're probably aware, doing a lot of your other inspections, people in residential, they don't typically aren't attuned to actually maintaining their systems very well. That, I don't know if people have any experience with that, but that's been my experience, is that just universally, it's hard to get people to do what they're supposed to maintain any type of systems in their house. When do they maintain stuff? A lot of times when it fails. And yeah, I talked about the conventional pits and galleries earlier, where just like I say, the conventional, they work really well, but they take up a lot of space. So they've come up with a lot of lots, these proprietary systems that you can fit a lot more in a lot smaller area. And then you have black water and gray water. The black water, it used to be at one time, and a thing to look for is, do you have separate systems? Nowadays, systems should be combined, the black and the gray water. The black water being things like toilets and stuff, and gray water being things like wash machines. Like I say, they used to have two different systems, and that was encouraged, but for quite a number of decades and stuff, that they just combined the systems into one. And another thing that you see, which a lot of times is pretty obvious typically, unless it's not very much, as they call raised systems, that you may not have that distance to bedrock or groundwater that you need. So how do you do it? You build the trench up. So you may have, when you go to install a trench, you may have the bottom of the trench may start 1 foot above the ground. And how do you do that? By bringing in a lot of fill to do that. Okay, we can move on there. And that, like I said, I talked about the proprietary systems. People can look at it, but again, it's really to be able to site fields in smaller areas is the whole idea of the proprietary systems. They get to be more expensive, by a lot of times quite a bit. In fact, a lot of times when you look at cost, it's not necessarily based on how much long a trench is. A lot of people think, oh, I have a 40-foot long trench that may be a proprietary system, and I have two 60-foot long trenches of a conventional system, and say, well, it must be cheaper to have the 40-foot long trench, but it may be actually cheaper to do the two 60-foot long trenches and actually be better. The best way to site a system, in my opinion, is to let Mother Nature do the work and spread out a system, as long as you can do that. If you start adding technology and stuff, then it gets a lot more costly. And like I say, Mother Nature works good by itself. Okay, you can move on here. Yeah, this is, I just talked about the long-term acceptance rate, and kind of shows that based on time, and that the amount of flow you're going to be able to put down on leaching fields is going to drastically decrease in that, and get to a more stabilization point. And if you have problems in your systems, it may eventually get to the point where the leaching fields aren't working anymore. Then we can move on. And yeah, if you're looking where dwelling where they abandon a system, how do you typically abandon a septic tank? Typically they clean it out, and you don't see it taken out too much. Typically they crush and fill it with sand, or if you ever might want to take it out later, they fill it with foam. They typically only bother removing a septic tank is if you might want to use that area later on, or you need to use that area for some other reason. And yeah, typically the abandoned leaching fields and the piping, typically stuff just remains in place. Like I say, unless you need to take it out so you can use that space, reuse that space.
The tank has to be a certain amount of feet from a house?
Yes, it does. And that it's typically, depending on whether you have a footing drain or not, 10 or 15 feet. If you have a footing drain, it's typically 15 feet. If you don't have a footing drain, it's typically 10 feet. And again, that's a code compliance system. If you're doing a repair, that you can get a potential exemption from that if you need to. Again, you have to just justify the exemption.
We see the tank sometimes, the tank under the driveways, under your decks, under porches and stuff.
Yeah.
What's your thoughts on that?
Yeah, no, I mean, there's no problem leaving it there, as long as you're doing it to make sure that you're not going to have any problems with settling and that. So that's why they typically, they don't just crush it, but you fill it with sand. So if you found in your inspection a tank maybe that was under the driveway, and they just drained the tank and abandoned it there, that could be a problem later on, because it could settle in your driveway, could collapse. So the key is, like I say, it's not the contamination that you're concerned about so much, but other issues, particularly settlement. And so that kind of the basics of stuff, and I'm going to go over. This is what you talked about for. There's a general permit when you have backwash systems, and that they shouldn't go to the same leaching fields, and for various reasons. I mean, one of the reasons it gets to be a complex chemistry of what you're putting down. You can have insoluble compounds that are developed, and that could clog up your leaching system. I mean, the amount of water, usually the amount of water is not that much from these systems, but that could be a problem. But you really don't want, and you're not allowed to anymore. And that, as you can see, this went into effect in 2014.
Brad, could you talk a little bit about water treatment, softeners, neutralizers, going into the septic?
Yeah, that's what I'm talking about. Those need to be separated. They should not go into the septic permit. And per this permit, starting in 2014, the date, they're no longer allowed. Now, the health department's not going to, unless you have some problem with your system, they're not going to come back and make you put a system in. But if you try to do any repairs or any changes to your system, and then you're going to have to put in a separate system. And typically it gets to be kind of like a mini leaching field is what it amounts to. You don't have any tanks or anything in between, but you're discharging with your neutralizer, your softener goes directly into the system. A lot of times it gets to be like, something that's 10, 15 feet long like that, and maybe 12 inches high. You can use like concrete galleries or stuff like. There's a lot of different systems that you can use.
Now, I was talking to a well contractor I know, and he had told me that neutralizers are okay in a septic system, but not softeners. Is
yes,
that?
that's correct. Yeah, calcite systems, they are exempt from this regulation. So neutralizer would be a calcite type system. It's limestone and that. So, but it's the salt that's probably the big thing, and any other treatment chemicals that you're putting in.
Thank you.
And that, yeah. So you don't have to do it just if all you have is a neutralizer, but if you have a water softener, you have to do this. And here, the requirements are a little bit different. I'm not going to go through them here for time purposes, but you can see that those are the requirements. And that. And these are just some, like I say, some other parts of record keeping and reporting. Again, if you put in one of these systems, it has to be done by a licensed installer. In some cases, a homeowner can do it themselves, and that's even for septic systems. There is in the regulations, if somebody owns a property, it's kind of similar. You're probably familiar with things like electrical and stuff, that a homeowner can do their own electrical, but they can't do somebody else's electrical unless they're licensed. Same thing applies to septic system installer. Needs to be done if it's not their primary residence. So it may be something to look at. Thing is, it's a pretty rare case when you see a homeowner actually installing their own system, but it does happen. And what's the quality of that? Depends on the quality of the homeowner's work. I mean, I'm sure that everybody's seen some electrical stuff, and a homeowner does it, and it looks professional and it's good. And other times it's a head scratcher. It's like, why would somebody do that?
Hey, Jim, I'm going to cut in for a minute. Kyle.
Yep.
You have questions?
Yeah, 6
You
questions.
want to turn your mic on and ask?
Yep. Yeah,
I'll get the other report going.
Yeah, get the next one, which is the one that says.
I'll get the other next one go while you answer some questions.
On it.
Yep. Just give me a minute.
Yeah, it's the septic system assessment, and that's the next one. Just
Okay,
let you know.
hold on.
Kyle, turn your mic on.
Yeah, just in case I have that one, in case we don't get to the third one for time wise.
Kyle, if you turn your mic on, then you can ask. Your mic's off. No, click your mic on, Kyle. Your mic's off. I can see it.
Yeah, some people are having problems with their mics and their.
Can you type it in? You can hear us. Can you type in one of the questions real quick? And then type the other one? No? Can you sign language it? Sorry.
Hey, Scott, if the people go to the line where it says Stan, there's a little camera on the third icon from the right. Click on that, then you can access the camera and your mic.
Yeah, I got it. Mine's over here on the bottom, on the right.
And if you're not using Firefox, it's one of the good browsers. So
yeah, I switched from Google and the other one to Firefox, and I have no problem since.
When they, why don't you, Kyle, if you can text your question to Stan or something, or I don't know who you're communicating with. But Bradley, why don't we go on with your photographs here?
Yep, that sounds good. Okay, this is a project I did several years ago, and I think a lot of this stuff may be, what I talked about, the practical part when you go out to do an inspection. You see the first couple of pictures and you see how the breakout. What's happening there is that essentially the microbes, which are aerobic, they need oxygen to work, that they're not working properly. And there's a lot of causes from that. It could be people putting a lot of chemicals down. I've seen actually even new systems where they start putting medicines down, and a new system can fail within a year. And that, because anything that uses a lot of oxygen is what a lot of times typically causes the thing. Now, obviously, it could also be the field was never properly installed in the first place. And that. In the old days, particularly older systems, one thing that they used to do is just dig a hole and put the system in. They didn't do any engineering. Remember, I talked about you have to have that distance to the groundwater and the distance to ledge. Well, you see some old systems that they dug the hole and they put the system in. I've had calls and stuff, and people say, "Oh, my septic system's failing in that part of the year, but it's working good the rest of the year." And I say it's probably failing in in the winter time, sometime around February to April or May. And they say, "Yeah, how'd you know?" And what's happening is groundwater in Connecticut can go up and down several feet between the high and the low, and the high part is typically February through April or May, depending on how much rain you get in April or May, and the groundwater is coming up. And that was actually the case in this too. Why is it failing and stuff? It worked good most of the year when the groundwater was lower, but it didn't work very good when the groundwater was higher. And that go back just to show the one picture. Yeah, this is the pump chamber. You see the picture on the lower right-hand corner, the pump chamber. In this case, what there was in the house, and I'll explain a big thing that we found in this house is that there was a main level of the house, but as you can see that if you look at there was a slope and there was a lower level of the house that was kind of a partially exposed finished basement. And what they were doing in this house is that it happens in a lot of houses in the basement that they have supposed to have a separate pump chamber just for if they have like a bedroom or they have a bathroom downstairs for that effluent. And that, so what it should have, and I'll show you in a subsequent diagram of this one, is that they should have the flow coming out in a large pump chamber. If they're going to put all the flow downstairs and then pump it out, have a large enough pump chamber, or have a separate line coming out of the house. So we can go to the next pictures. Go down next page. Yeah, this is the pump chamber. These are things to go back a little bit. This is the first picture of the pump chamber. Notice that the lid is cracked, and there's black marks on it. What that's indicated, those black marks, is something to look for if you pull a cover off. And that if you start seeing those black marks, what that means is that at times that the water level in that, whether it's a septic tank or a pump chamber, you see for the next two pictures, you see the same thing as for a distribution box and the septic tank, all the black marks. That means that the water has risen high in the tank or the distribution box, which it shouldn't have done that. That is an indication of a problem that you're getting backflow, and that or the flow is not going out to the leaching trenches like it should, because the trenches aren't accepting it.
Bradley, I've come into a couple of instances where the back baffle has a filter that can get clogged. And I've had some septic guys tell me that they just removed the filter, that it's been causing a lot of problems.
Yeah. Well, in 2000, the state of Connecticut added to the regulation. Yeah, that's a good point. Where for any septic tank, and that you have to have an outlet filter. And what that is supposed to do is to trap any type of sediment or fines, things like that, from going out to your leaching fields. Because once you go, stuff like that goes out to your leaching field, depending on what it is, that's when you can cause failure in your system and that. So there's a good purpose for having them in there. And to take them out there, you take the cover off, which may not always be quite so easy if the cover's down a few feet. People have probably seen some septic tanks that are right near the surface, but they could be down 3-4 feet too. I've seen ones that deep. So it may not be so easy to the cover, but you remove the cover and you just wash off the filter. But it kind of goes back to the same concept I talked about there with pump chambers being actually a better type of system, and that, but typically homeowners, they don't know about it, or they don't maintain the system. So that can be a problem. They're a good thing to have in there in summary, but if you don't maintain them, they can cause you problems.
Yeah, they can back up.
Yeah.
Brad, I don't know how much you got left.
Yeah,
I got the questions. Some of them are pretty quick. I don't want to take away from you, but I just had the questions that he had. Did we lose Brad?
Okay, yeah, let me just finish this up here in a couple of minutes, and then I can skip the last presentation if we want there. To go back in that, I'll finish this one up in 5 minutes or less, and then we can have a 10-minute question and answer period. Okay, this is what I was talking about, and you see in the next diagram that they have a pumping system. Suppose if you look at that last picture, I said a wall patch of hole drilled in the gravity effluent line, and that you look there and you don't see any piping, do you?
No.
I mean,
No.
that they patched it and stuff. And if we go to the next diagram, which is not picture, but go to the next page, the diagram, and that if you look at that, and there's another diagram that may be easier to read. Go down one more page. Okay, so this is the diagram from the installer. If you notice there at the top, kind of where it has a number B over by where it says house, and it shows a line going into the septic tank.
Right.
And that, well, I just showed you the picture. Did you see any piping there in the interior?
Nope.
No line. Yeah.
Yeah, no line. We actually went out there because this was part of a legal case I was involved in, and that we went out there with a backhoe and we verified there was no line there. Yeah, I mean, the installer saying that he installed a line, but
There's none.
there wasn't. And what was happening is all the stuff you see. Go just lay on that page. You see where it says pump chamber, has a PC for pump chamber before the septic tank. The pump chamber is supposed to have enough volume of storage in it for at least a day's worth of effluent in case that the pumps fail. And typically what you have, like remember I talked about earlier in this part there, that this had a lower level basement. That pump chamber is really designed just for that lower level basement, and that a reduced volume, and that with the main volume coming out of that line that wasn't there. And so that was one of the problems that I was hired by the homeowner to look at it, and we found out there was no line. It's like the system wasn't installed properly, obviously. I mean, that causes big problems. And that's one of the reasons that the pump chamber that I showed you that picture has the black marks. That was too much effluent going down. It wasn't nearly sized enough. It was only sized for that bathroom downstairs, not for the whole house.
Why don't we go to question and answer? Scott, did you have stuff?
Yeah, these are from Kyle. First question: is there such thing as a septic system being too big for the property?
No, not. But what I would say that no, it's not. As long as you distribute the effluent fairly reasonably evenly, and that what I've seen a lot of times in systems, and that is you have a particular type of system and they just dump into one end of the system. And what happens a lot of times with those type of systems, you get what they call progressive failure, and that because you dump it into one end and you're using just a small section of your septic of your leaching field, but over time that part fails, and then it goes a little bit farther down because the one part that fails is not accepting water, and it goes to another part of the system, and eventually that fails, and so on. And that's what they call it, progressive failure, that eventually the whole line in the leaching field ends up failing. So like I say, as long as it's being distributed, but if a lot of times with some large systems, you may have that where you get that progressive failure where it's not practically using much of the leaching field at one time.
Next question from Kyle: what kind of foam sealer for decommissioned tanks?
It's just the idea of the foam is to make it strong enough. It's just a typical foam that you use, and that really what you're trying to do is prevent collapses. And,
like a closed cell foam that they would use on insulation, similar to that?
Yeah, something like that.
Okay.
Yeah, like I said, the only reason that you really use foam is that you don't want to take out, if for some reason you don't want to take out the tank at that point in time, but you don't want to have to, at another point in time, dig up crushed tank and sand and that, because that gets to be very difficult to do with very heavy materials. Obviously, you have a whole tank full of sand and you have crushed concrete. Not that it can't be dug up, but that gets to be a problem as far as.
But probably in most cases, because when you replace a tank, they pull it out. They could pull it out, and it's not that difficult.
Yeah, I mean, that's probably the better way. If that tank, you think it might be in a problem because of needing the space in the future, you're probably better off taking the tank out at the time as opposed to using the foam. But not everybody does that.
Now, we always talk about the garbage disposal issues with the septic systems. You know, a lot of them are still out there. We still see them. We tell them why. Can you just explain why garbage disposals aren't good for a septic system?
Yeah, well, I qualify it that they're not good if you're putting a lot of material down. Again, I've talked about in several things, you know, people using medicines or chemicals, or another thing is food scraps, any of that type of stuff. The reason that I assume that if you assume that a septic system has been properly installed, no, they've got those separation distances and everything, that it's not sitting in groundwater and that, but it's a properly designed system. And that typically the reason that they fail is because of, as I said before, the microbes that are aerobic, that they need oxygen, and once you start devoiding stuff, you put food scraps, that takes a lot of oxygen for the microbes and stuff, and it uses the oxygen on the things like food scraps and stuff. So essentially what I would say about garbage disposals, in of itself, it's not bad to have a garbage disposal, but it's bad if you use it and you start putting a lot of food scraps and stuff down, which is easy and convenient. A lot of people will do that. But those things like if you have, let's say you're peeling potatoes and that, what somebody should do, instead of just washing all of them down with using the garbage disposal, take the majority of them out, so you don't have that much left. So it's a matter of how you manage that garbage disposal. But again, the problem is for people, it's an easy way just to get rid of stuff. It takes more effort and stuff to scoop the material out and not put very much down.
Is it legal?
It is legal. You can oversize your tank by typically 250 gallons. It's legal to do.
You can have a garbage disposal on a septic. That's legal, or is it illegal?
Yeah, it is legal to do, but you have to oversize, make a larger tank.
What
Okay,
about
so-
the enzyme injectors you'll see?
Yeah.
Make it more friendly to the septic system. Are they a benefit? And if somebody doesn't put any of the enzymes in that tank, which they run dry all the time, it's basically a standard.
Yeah, it really, in my opinion, the enzymes are just they don't really work that well. You can fix a septic system if there hasn't been, I don't think of the way to word it there, something to make the system so it's unusable. If it's unusable because you don't have enough oxygen down there, because it really comes down to having oxygen. That's why I talked about, like, somebody with medicines take a lot of oxygen, that can make your system fail. What you can do, kind of, again, similar to, I mentioned the compost pile, is what do you do with the compost pile every so often? In that, you go and you turn the compost pile. And that.
One thing, can somebody with health issues, can the system be overwhelmed with water? I guess the question is what the size. Again.
If you put enough down there, but that's probably unlikely, because again, with what they make you oversize these systems for, I mean, typical household that, like I said, for a residential, they're figuring 150 gallons a day for the first 3 bedrooms. That's a lot of water.
Right.
And that. So there's so much safety factor that I'm not saying it can happen, but it'd be unusual. I mean, probably typically nowadays, because you've had these low flow fixtures for decades now, that people have them, that they just don't use anywhere near that amount of water.
Bradley, when we're at a home inspection and the septic guy's out there and he inspects the system, if the system passes or fails, does a certain amount of reporting have to be done to the town either way?
No, not to the town. John, for a real estate action, no, not for the town. And yeah, one thing I'll just mention too is one thing to look for with your inspections, because typically what they should do is they should pump the septic tank as part of the inspection. And that's not always done, but that's what should be done. And one thing to look for is when they pump the septic tank, do you see the effluent coming back from the leaching field into the septic tank? Just visually observe it. If it is, that indicates problems in the leaching fields. You shouldn't get what they call backflow from the leaching fields into the septic tank. And like I say, you would notice that when they're pumping the tank, you'd see water coming back in.
So if a tank fails, there's no reporting to the town sanitarium or the town public health?
No, not for real estate. That transactions,
Okay.
what you're talking about. No, it's not required.
Okay.
So the next question, Kyle, I can kind of answer it quickly based because I have one on mine. I think he wrote condensation line running at the city sewer okay without water treatment. If it's a high efficiency furnace, boiler, any high efficiency appliance, they're supposed to have a condensate line or not a condensate, a neutralizer on it. And I have them on all of mine. I just put another one on my water heater or my tankless water heater. And I see them all the time, and there's nothing in our standards say we have to point it out, but I mention it. I think the question is, and I'm just curious, can a condensate line, acid producing gas appliance go into the septic system without a neutralizer, or does that have to require a neutralizer because it's the condensate so acidic, Brad?
And that, from a practical standpoint, I don't think that there's a legal thing that has to, but from a practical standpoint, yeah, you'd want to have a neutralizer, and that's going to cause you problems in your septic system and your leaching fields.
And even if your pipe is cast iron or leading out of the house,
yeah, it's going to corrode the pipe too over time. And that.
Yeah, that's a plumbing requirement, Scott.
Yeah.
Yeah, it's from my knowledge, you've got to have it, even if you're going into city sewer.
Yeah, I'm just saying that, we don't do code inspections. We certainly, we point out a lot of stuff, safety, and a lot of those safety issues are the issues that we find are code. But yes, I'm seeing it more and more. I see a lot of guys putting in furnaces yesterday and they don't put it in. And if they obviously didn't pull a permit, and at least I know some of the towns that I deal with would call that out. One other thing I was going to ask Brad, and I can't remember too. What's the distance? You might have said it, and if I did, I apologize because I was. What's the distance from a well? Did you talk about the distances from a well?
Yeah, depends on and it's in the presentation, and that depends on the required flow rate from the well. But for most residential, in that it's going to be 75 feet to be code compliant. You can get it again for a repair. You can get exemptions from that 75 feet.
So if it's not compliant on an older house, if the system fails and they have to put a new system, and then they got to bring it up, whether it's engineered, some towns where you see they have to you have to come in and do an engineered system. Is that correct?
Yeah, yeah. The engineered systems, as I said in the one presentation, there's certain requirements, but there's actually not very many requirements that require an engineered system. Typically, though, you see several towns in Connecticut, and when I talk to sanitarian, they're doing it for liability. So you see some towns that they just say that you have to have an engineered system, and a lot of times they're protecting themselves. I know, like I've done some work in Stonyton, and they required engineered systems. And when I talk to the people in the town, it's like, well, they got sued and lost a lawsuit and stuff. So they just say all systems have to be engineered to protect themselves. So there could be just some simple reasons like that.
Thank you. I think that he had best clues. Any other questions?
Yeah, I think we're doing good. How about above ground swimming pools?
Yeah, if you look at there's the separation, there is a requirement. I'd have to look at the regulation.
It's like 25 feet.
Again, I don't remember offhand, and that I'd have to look at the table. But for a lot of stuff, there's different distances from property lines to sheds to swimming pools, any type of structures, and that there is separation distances. And you look at the particular table and the regulations.
Gotcha.
And that.
All right. Well,
I just mentioned about septic inspections a lot of times that they can vary a lot and that, but typically for residential septic real estate inspections, what they're doing is that they're just saying that whether the system is working acceptably at the time that they do their inspection or not. They're not really making any, some of them that they may go farther with their inspection, but the majority are just, like I say, it's no yes or no, is it working properly at the time? And you could have some situation, like I had one situation is involved in that people had an inspection that they bought a house and it was one person that was living in the house for a number of years and the system was working just fine. And then they moved in and they had a couple of teenagers and their friends, and their system failed about within a year because they were a lot more use, and did the inspection and found out that they didn't have that much of a septic system. It worked fine for one person and that, but when they quadrupled the flow or more, that over a short period of time, it failed. So like I said, an inspection a lot of times may not be so detailed, and that it may be just a simply answering the question, is it working right at that point in time or not under those conditions?
And I know that we're at 8 o'clock, but Brad, correct me if I'm wrong. I've been told that a cracked, failing tank, leaking tank is not a fail, it's a repair. Is that correct? Like,
yeah, that's what I talked about. Anything, if there's an existing system and you're replacing anything, that's considered a repair as opposed to a code compliant system necessarily. I say it could be or could not be, but, and again, the repair means that they can give you, that the sanitarians can give you an exemption. So let's say you had a septic tank that was cracked and you want to replace it, that's a repair. But let's say that septic tank, because you maybe don't have enough room, is only 5 feet from the foundation. Right. That if you want to do a new one, you have to have that 10 or 15 feet, depending on, like I say, whether you have a curtain drain or not around the house. The repair, they can give you exemption to replace it at the 5 feet. So it's really whether the exemption can be granted or not. If it's a new one, the town sanitarian doesn't even have an option. Like I talked about in the property line, if you can't maintain 10 feet from their property line, the sanitarian has to say you can't put the structure up because I can't give you an exemption. I'm not allowed to. By the repair, they can give you the exemption.
Thank you, Brad.
So I will tell you the last thing I will mention on the home inspection and on report writing, you want to be careful because you're going to identify whether it's city sewer, well water, public water. I know in all my home inspection reports, I put in that the system is septic per the client, per whoever, per the field card. But I also put a note in there that I recommend that the homeowner check with the town to make sure that it is septic or it is city, because I can't tell you, I've gotten calls, hey, my septic backed up. Okay, well, what do you want from me? Well, I thought I had public. So just for report writing, to cover yourselves, you want your client to double check with the town to absolutely make sure, especially if they're not getting a septic inspection, they think it's public, it's possible that they could have a septic. So little advice. Well, yeah. Thank you very much, Bradley. Right. Is there anything else? Any other questions? Cool. Certificates will go out in the morning. If you had problems with video, go to our website under Click Meeting, and you'll see the browser there. Firefox is the best one to use, but I'll also put some notes in there to help you in the future, and we'll address those issues as needed. Thank you very much, everybody.
Good night.
Good night.